And welcome back. The purpose of this video is to go over the quiz questions, the practice quiz or test questions at the end of the packet. This is pretty much the last step before we take the test. So we want to know not only what the right answers are, but how do we get the correct answers when we're presented with the different information on the test. So let's go ahead and jump right in here. Which element is a noble gas? Well, we can go look at the periodic table. We have the noble gases right here in group 8 or 18. Helium, neon, argon, krypton, xenon, radon. So that one is pretty much a give me. Number 2, atoms of the noble gases are generally inert. Inert means non-reactive. They will not react with other elements. That's why they're noble gases. Now the question is why? Well, it's all about electrons. These gases have full valence electron shells. Their outer energy levels are full of electrons, therefore they will not react. And that is answer D. 3 elements, X, Y, and Z, have consecutive increasing atomic numbers. If element X is a noble gas, what will be the symbol for the ion of element Z and its compounds? Wow, we're actually going to have to think about that a little bit. So, if X is a noble gas, let's just say X is neon. That means this would be Y and this would be Z. So Z is going to be in group 2. Well, and see, it doesn't really matter where we put X. If X is here, then Y would be here and Z would be here. So no matter what, Z is going to be in group 2. And we know that group 2, when it becomes an ion, it will become a cation and lose 2 electrons. So it will be 2 plus. And so Z would be Z2 plus. Which of the following describes what takes place when iron is oxidized? Well, this is exactly the same example. When you lose 2 electrons, remember electrons are negative, so when you lose electrons, we have more protons, which are positive. We're never really gaining or losing protons, it's just gaining or losing electrons. So in this case, if we lose 2 electrons, we'll have 2 more protons, and it will be a 2 plus. Electronegativity differences are often helpful in determining the bond character between 2 atoms. A general rule states that if the electronegativity difference between 2 atoms is greater than 1.67, an ionic bond would most likely be formed. Which pair of electrons would probably form the strongest ionic bond? In this case, we just have to do a little simple math. Aluminum is 1.5. Phosphorus is 2.1. The difference between these is 0.6. Potassium is 0.9. Fluorine is 4.0. The difference is 3.1. Sodium is 1. And chlorine is 3.0. Difference is 2. And right here we have calcium is 1 and oxygen is 3.5. The difference is 2.5. Well, we have a couple of ionic bonds here, but this will be the strongest because it has a 3.1. So the answer is C. Which of these is an ion with a charge of 1 plus? Well, let's just get rid of the neutrons. What is a 1 plus ion? That just means we have 1 more proton than electrons. And we see we have this right here. This would be a 1 plus. There's 1 more proton. Now if there's 2 more protons, this would be 2 plus. These are the same, so that's neutral. And this has more electrons, so that's going to be a minus 1. So the answer has to be 1. Cations are formed when neutral atoms lose electrons. Anions are formed when they gain electrons. A chloride ion has the same number of electrons as a neutral atom of. Well, let's check out chlorine. Chlorine is right here, it's a halogen. So chlorine has 17 protons and 17 electrons. But it is likely to gain an electron to become chloride. So here comes the electron. Whee! So it had 17 electrons, but now we have 1 more. That means it has 18 electrons. It has 18 electrons to make it a chloride anion, and well, this is a neutral element. Argon, that has 18 protons and 18 electrons. And that is the answer. The correct formula of an ionic compound containing Al, 3 plus, and CO3, 2 minus is, and on a test, just write this out. When in doubt, write it out. There's no shame in that. Let's do the crisscross rule here. This 2 will be down here. This 3 goes right here. Remember, this 3 has nothing to do with this 3. Never change this number here. Get rid of these charges. And now we have two numbers here, so we have to put a parentheses. Al2 parentheses CO3 3. And that is an answer right here. Using the table above, what is the correct formula for ammonium phosphate? And luckily they've given us the actual formulas here. We have ammonium and we have phosphate, PO4. Yet again, this is a 1. Let's do the crisscross rule. Do not mess with these numbers. 3, 1. Well, if it's a 1, we don't use it. Get rid of these right away. So what we have is ammonium, NH4. We have 3 of them. And then we have PO4. Is that an answer? NH4, 3PO4. Yes, it is. The correct name for MgI2. Well, Mg, if we went to the periodic table, is magnesium. And this is iodine or iodide. So, let's go check this out. Magnesium is in group 2. So magnesium doesn't need a Roman numeral ever. We just cross this out. That can't be the right answer. And also we know the second anion has to be "-ide". Can't be "-ite". So let's just cross that out. And this makes no sense, so the correct answer is going to be A. What is the correct formula for aluminum chloride? Well, aluminum is 3 plus. So that makes sense. And remember, chlorine is a halogen. So chlorine is going to have a -1 charge, 1 minus charge. If we do the crisscross rule, it should be Al, get rid of this, we don't need the 1, AlCl3, which we have right here. And if you didn't know that aluminum was 3 plus, you could go back up to the periodic table and you can look at where aluminum is, which is in group 3 or 13. Everything here is a 3 plus. This is 1 plus, 2 plus. Oops, I'm on the wrong page. Where do I go? Okay, here we go. The formula for lithium nitride is, well, lithium is in group 1. Lithium is going to be 1 plus. Nitrogen is actually going to be 3 minus. And how do I know that? Here's nitrogen right here. This will be a -1, -2, and we've gone over this before. -3. These will form anions, so it has to be -3. Do the crisscross. 1. We don't need the 1. Get rid of all these. So we have Li3N. Li3N, lithium nitride. When ionic compounds are named, the name of a monatomic anion will end in which of the following suffixes? That's a give me question there. It has to be "-ide". We've gone over that a lot. Which of the following is the correct name for the compound MnF3? Well, Mn is manganese, and that's our only choice. If we look at the table, manganese is actually a transition metal, so it could use a Roman numeral. And I keep going to the wrong page. And F3 fluorine is actually a halogen, so it's going to have a 1 minus charge. There's 3 of them, so 3 times, think of it like this. So all those together are going to be 3 minus. So that manganese has to be a 3 plus, which means it has to have a Roman numeral 3, so it can't be this, and it can't be this. And also there's never a Roman numeral after the anion, so B is our answer. What is the chemical formula for iron 2 phosphide? Well, You could go back to the periodic table, get iron, and we know right here the 2 is telling us it's a 2 plus. We could go back to the periodic table and get phosphorus, which is going to be a 3 minus because of where it's located. Then we just do the crisscross. Bam, bam, Fe3P2. And it's D. When naming a transition metal that has more than one oxidation number, the numeric value of the oxidation number is indicated by, and that is a softball over the plate. That is an easy answer. The correct name for Mg3PO4 is, well, this is magnesium. There's 3 of them, but we know the cation is always just called the metal's name, so it can't be trimagnesium. And also we know magnesium is in group 2 if you go back to the periodic table, which means it never has a Roman numeral. So we can cross that off. And then you're just going to have to memorize that that's 8, phosphate. What is the name for NH4OH? Well, unfortunately, this question is just straight memorization. This is ammonium and this is hydroxide. You have to memorize your polyatomic ions. An alien astronaut landed on Earth and created the periodic table shown. The astronaut was trying to determine what type of bond would be present in several compounds. The type of bond in a compound containing G and E would most likely be, well, we've been studying ionic bonding now for 2 weeks, so that's probably the answer, but why isn't it covalent? Covalent bonds happen between gases, so for instance, or non-metals, so D and B would be covalent, D and E. This is basically a hydrogen. This could form a covalent bond with something over here, possibly. Although hydrogen is a little odd and it does weird things. And metallic bonds have to be between metals, so maybe between like C and F would be some sort of metallic bond. Alright, moving on. Chlorine and bromine are in the same family in the periodic table. According to the information in the table above, what would be the correct formula for sodium bromate? Well, we know sodium is Na, and if chlorine and bromine are the same, that means they'll form exactly the same sort of anions with charges. So instead of ClO, it will be BrO. That would be hypobromite. BrO2 would be bromite, and BrO3 would be bromate. So Na is in group 1. It has to be a +1. Bromate is a -1 charge. See how these cancel out? Bam. So it's just going to be NaBrO3, which is the answer. Which of these is most likely to form between elements transferring electrons to form oppositely charged particles? That's a fancy way of saying an ionic bond. Which of these compounds is most likely to contain an ionic bond? Well, we have to realize ionic bonds occur between metals and nonmetals. So let's see what we have here. Hydrogen and hydrogen, that's not going to work. These are nonmetal and nonmetal, not going to work. Nonmetals and nonmetals, not going to work, so it has to be calcium and chlorine or chloride. One example of an ionic compound is, yet again, fluorine and fluorine, not ionic. Carbon and oxygen, not ionic. Hydrogen and bromine, and then here we have magnesium and chlorine. This is the best example right here. Magnesium and chlorine. 10. Which compound contains both ionic and covalent bonds? And like I said, hydrogen is just sort of wonky. It's just sort of weird. Here we have CH4. These are basically non-metals, not going to work. Nitrogen, hydrogen, not going to work. Okay, here's the crazy thing. Ammonium is nitrogen combined with these hydrogens. These are actually covalently bonded to make ammonium. And then it's going to lose it will lose an electron to make it a +1 charge, NH4+. So this is actually the answer. I know what you're saying. Well, what about this? Well, the thing is, that's a magnesium. And here is a bromine a bromide anion and a bromide anion. These just sort of connect. This is like a formula unit. So these aren't really connecting. These aren't really bonding. So actually the answer is A. Which compounds are classified as electrolytes? Okay, electrolytes are basically ionic compounds that you throw into water and they break apart, they dissociate, and then it can conduct electricity. So let's look down here and see what's an ionic compound. We have potassium and we have nitrate. Potassium nitrate, that's ionic. This is weird. We haven't gone over this a lot. You're thinking, wow, this is hydrogen. You just said that sometimes this is covalent, sometimes it's not. But this is actually sulfuric acid. That's the name of this right here. This is actually ionic. These H2s and this sulfate connect ionically. See how this is just carbon, hydrogen, and oxygens? Not ionic, not ionic. Let's cross all those out. Here we have potassium, nitrate, and here we have sulfuric acid again. So our only choice is A. That's a difficult question. The type of bond found in magnesium chloride. Another softball across the plate. Ionic. Which one of the following substances is a weak electrolyte? Well, here's the thing. We could go down here and see what these are, but it doesn't really matter. It doesn't matter if you know anything about these at all. All we need to know is if we throw something in here, it's actually an electrolyte, which means it's an ionic compound that disassociates in here. If it's a strong electrolyte, the bulb will glow brightly. So this is a strong electrolyte. This is actually sodium bisulfate, sort of one of those odder ones we haven't gone over a lot. Bulb glows dimly. This is not, well, it glows dimly. So this could be a weak electrolyte right here, even if we have no idea what that is, which this is formic acid. And we haven't gone over that. Okay. And down here it doesn't glow at all. So this can't be an electrolyte at all. This is not an ionic compound. Bulb glows brightly. Okay, well this is nitric acid, but it's ionically bonded, so this is a strong electrolyte. Strong electrolyte, this has to be the answer here, C. Sort of a difficult question. It's like easy, but if you think about it, it could be difficult. Okay, well I hope that helps you. I hope that helps you prepare for the test. Just keep practicing and going over these things, and if you need any help, let me know.